So this is a question from GATE 2025, and the question is, consider a part of an electrical network as shown below. Some node voltages and the current flowing through the 3 ohm resistor are as indicated. The voltage at the node X is, so I need to find what is the voltage here, right? And given there is a 1 ampere current flowing through 3 ohm resistor. Given this is 9 volt, okay, and there is 1 ampere current flowing through 3 ohm. So what should be the voltage here? Okay, so from this network we know the current flowing through 3 ohm resistor is 1 ampere, right? So 1 ampere, so we can relate this 1 ampere as 1 ampere equal to the voltage drop across 3 ohm, that is this voltage minus this voltage, that is 9 minus, I will call this node voltage as y. Okay, so 9 minus y by 3 is 1 ampere. Okay, so from here, so 3 is equal to 9 minus y, right? Or y equal to 9 minus 3, or y is actually equal to 6. So 6 volt is y. So from this, this node voltage is actually 6. This node voltage is 6. So I'll just clear this off. So y equal to 6 volt. Okay, so since this is 6 and this is 8, definitely there will be current flowing like this, right? So what is this current? I. This I will be equal to the voltage across these two nodes, that is 8 minus 6 by the total resistance. So total resistance is 2 and 1, right? So total resistance is 2 plus 1 is 3. So it is 8 minus 6 is 2. So 2 by 3 is the current flowing through this, right? Now again, if we check here in the circuit, this current is flowing through this 2 ohm resistor, right? This is 2 by 3. Okay, so from the circuit, this current 2 by 3, so I equal to 2 by 3 is equal to node voltage minus this node voltage, that is 8 minus x by the resistance 2 ohm, right? By 2 will be equal to 2 by 3. Okay, so from this, if I cross multiply, it is like 4 by 3 is equal to 8 minus x, or x will be equal to 8 minus 4 by 3. So it is equal to 24 minus 4 by 3, or it equal to 20 by 3. So x is equal to 20 by 3. So the actual answer is A. Yeah, so this is a question from GATE 2025. The question is, let IC, IL and IR be the currents flowing through the capacitor, inductor and resistor respectively in the circuit given below. The AC admittance are given in Siemens. Which one of the following is true? So it has been given in RLC circuit here, and the admittance of each of these elements is given in Siemens, right? And if you could see here, the input voltage is also given, okay, and this is in polar form, and this is the voltage across the capacitor, inductor and resistor. So question is, what should be the current through the capacitor C, inductance L and resistance R. So since each element is in parallel, the current will be like the current through the element will be equal to the voltage across this. So if this is the voltage V in, then V in by the impedance of the element, okay, or so this is the impedance, or we can write as V in into the admittance. I will call it as A, okay, V in into A, okay, admittance. So some element, right? So Xi or Ai, corresponding to Xi means the impedance of the element, and Ai is the admittance of the element. Ai is 1 by Xi, right? And here given is Ai. Okay, now we'll find the current. So before that, the given current voltage is in polar form, that is like in this form. So magnitude, angle, right? Magnitude and angle. So we should note that if two values in polar form, like m1 angle theta 1, m2 angle theta 1, I am multiplying, then the resultant will be like, we should multiply these terms. Magnitude will be m1 into m2, and angle will be like theta 1 plus theta 2. right? So this is what we have to keep in mind. So we'll find here the angle current IC. So current IC is equal to the voltage across the current capacitor. So 1 angle 90, that is a voltage, into the admittance is J25, right? So we can write in polar form this as the magnitude is 0.25 and angle is 90 degree, because it is like A plus JB form, only J is there, right? And here the magnitude is 0.1 and angle is minus 90. Why minus 90? Because the magnitude is minus J, right? So that's why. And here the admittance is, since it is only resistor, so we can write 0.2 angle 0. So this is the admittance. 0 in the sense like it is having only a real term, and these two are having imaginary term, right? So the current IC will be equal to 1 angle 90 into the admittance of capacitor, that is 0.25 angle 90. So this is 0.25 into 1 is 0.25 angle 90 plus 90, right? 90 plus 90. So this is 0.25 angle 180, right? So similarly the current IL, that is current through inductor, IL is given as the voltage across the inductor, that is 1 angle 90 into its admittance, that is 0.1 angle minus 90. So this is equal to 1 into 0.1 is 0.1 angle 90 minus 90. So this is equal to 0.1 angle 0. And the current through resistor IR is as the voltage across it, that is 1 angle 90 into its admittance, that is 0.2 angle 0. So 1 into 0.2 is 0.2 angle 90 plus 0, right? So it is 0.2 angle 90 degree, right? So 0.25 angle 180 through IC, 0.21 angle 0 through inductor, and 0.2 angle 90 through the resistor. So option is A. Yeah, so this is a question from GATE 2025 and the question is the Z parameter matrix of a two-port network relates the port voltages and port current as follows: V1 V2 equal to Z into matrix of I1 I2, right? So I can expand this here as V1 V2 equal to Z11 I1 plus Z12 I2 and V2 equal to Z21 I1 plus Z22 I2, right? So this is can be expanded as like this, okay? The Z parameter matrix with each entry in ohms of the network shown below is, so we need to find what is this Z. So Z is, according to this equation, Z is Z11, Z12, Z21, Z22. So how to find? We just need to find the this relation, and we will find Z11, Z12, Z2 and Z22 of the circuit, okay? So if we analyze the circuit, we can analyze in many ways. We can either use the mesh analysis or nodal analysis, but it will take it will be a lengthier process. So instead of that, what we will do is, like here we have a delta connection, this 2 to 2 resistance forms a delta connection. So we can convert this to a star like this, okay, and then we will apply the KVL. So it will be easy. So how to convert this? So if I will draw here, so this is our network, okay, and I want to convert this to such a network, star connected, okay, and say these resistance are R1, R2, R3, and say this is RA, RB and RC. So what is the relation? RA, I can find this RA as R1 into R1 into R2 by the total resistance R1 plus R2 plus R3. Similarly, I have RB as R2 into R3, R2 into R3 by R1 plus R2 plus R3, and RC as R1 into R3 by R1 plus R2 plus R3, right? So here since all R1, R2 and R3 are 2 ohms, right? So here R1 is 2 ohm, R2 is 2 ohm, R3 is 2 ohm. So RA will be equal to RB equal to RC. So I just need to find once what is the value of these terms. right? So what will be RA? RA will be equal to 2 into 2 by 2 plus 2 plus 2, right? So it will be 4 by 6 or it will be 2 by 3. So this is same as RB equal to RC. So I can replace the circuit with this network with the value 2 by 3, 2 by 3 and 2 by 3, right? So let me draw that. I will redraw the circuit with this. Okay, so here I have one resistor, 2 and 3, right? So say if this is A and this is B, so this node is A and this node is B, like that. Okay, and say this is C, which corresponds to this node. Okay, so these resistors are 2 by 3, 2 by 3, 2 by 3, and this resistor is 2, 2, and I have the voltage V1 and V2 here. Okay, and the current flowing through this resistor is I1 and this resistor is I2. Okay, and this is a node, right? So since the current is I1 and I2 from left and right, the current through this resistor will be equal to I1 plus I2. Okay, so we can apply the Kirchhoff voltage law in each loop. So I'll apply the Kirchhoff voltage law in first loop. Okay, KVL in loop 1. So what happens? I have V1, this voltage, minus the voltage drop across this resistor and this resistor. So minus I1 into 2, okay, minus the voltage across 2 by 3, right? So I1 into 2 by 3 minus the voltage across this one. So minus I1 plus I2 into 2 by 3 is equal to 0. Or V1 I can write as, I can club the terms of I1, right? So 2 plus 2 by 3 plus 2 by 3 plus I2 into 2 by 3. Or so if I club this, it will be 4 by 3 plus 2, or it is equal to 10 by 3, right? I1 plus 2 by 3 I2. So this is V1. Similarly, if I apply the KVL in this loop, loop 2, right? So current is flowing in this direction, so plus minus will be drop here also. Okay, so I can write V2 minus the voltage drop across this resistor, right? So minus I2 into 2 minus the voltage drop across this 2 by 3. So again the current flowing is I2. So I2 into 2 by 3 minus the voltage drop across 2 by 3, that is I1 plus I2 into 2 by 3 is equal to 0. So I can write V2 as the first term I1 into 2 by 3 plus I2 into 2 plus 2 by 3 plus 2 by 3, or 2 by 3 I1 plus it is same as the previous, so 10 by 3 I2. So this is V2. So from here I can write, this is Z11, right? So Z11 is equal to 10 by 3, Z12 is equal to 2 by 3, and from here Z21 is equal to 2 by 3 and Z22 is equal to 10 by 3. So that is a matrix, right? Z11, Z12, Z21, Z22. So this is 10 by 3, 2 by 3, 2 by 3, 10 by 3, right? So the answer is option A.